Welcome. Let's talk about division. So we talked about multiplication previously. Division is often thought about undoing multiplication, and we're going to explain that a little better. That's part of what the big part of our question is. But we're also going to do this using what's called partitioning model, which is a really good way to think about that is how do I split something into equal parts? And we'll then talk about from there repeated subtraction, which just like remember, multiplication was repeated addition. So the opposite of addition is subtraction. So the opposite of multiplication is division. So we do repeated division. So these are three main models we're going to go through. So forget even the standard long division algorithm, other things. Often actually now they want us to teach students these models first before we ever do the long division algorithm. All right, so let's go through these different models. The partitioning model, so for instance, if I have 18 cookies, and I want to break it up between Bob, Dean, and Charlie, well, what I can literally do is I can go through and do this one cookie at a time. So I give this one to Bob, this one to Dean, this one to Charlie, this one to Bob, this one to Dean, this one to Charlie, this one to Bob, this one to Dean, this one to Charlie. Bob, Dean, Charlie, Bob, Dean, Charlie, Bob, Dean, Charlie. Well, now we just come down and look at how many is in each one. And we see that 18 divided by 3, because I've broken into those two groups, is 6. Now, another way to have done this, I'm just kind of clear my own writing, where I took this, if I grouped, so what if I circle 3 of them? Now, circle 3 of them. Now, circle 3 of them. Well, we keep doing this because every 3 is going to, one of them is going to go to each of those students or those friends. Well, notice I have 6 groups of 3, which tells us we have that amount. All right, so this is a really nice visual way. Give students a whole pile of what they're dividing and tell them to break it into this many equal groups and let them go at it. There's lots of ways they can. No one is better than the other. They actually are really good for different students for different reasons. All right, switching gears, we can talk about the missing factor. And this one works a little bit better. It actually almost introduces the idea of algebra because what we're simply doing, if they know their multiplication tables, they're super good at the multiplication, we say, okay, 3 times what is equal to 18? And that makes more sense when we go back to that previous example where we took 3s, we said groups of 3. Well, now we say, okay, the groups of 3, I'm saying how many groups? Since there's 3 in each group, 3 times what? And again, if you learn multiplication this the opposite way, where you have 3 rows of something and how many rows would have to add up to 18, that's actually how this works out beautifully. And we can do this 3 times 6. But this only really works if a student is comfortable with multiplication. Whereas this model, they don't have to know multiplication. They literally can just manually do it. However, this really hard to handle if the number is large. This much easier to handle with large numbers, kind of, but it requires a lot of multiplication back then. So in general, division is actually undoing multiplication. That's why this ladder model makes a lot of sense because division, it went backwards on me, sorry about that. A divided by B is C, only if B times C is equal to A. Now notice, I took the number that was being divided by, and I moved to the other side. Now, in particular, we call A the dividend, B the divisor, because it's thing I'm dividing by, and C is the quotient. Now, sometimes people write this 2 other ways. Notice one of them is a fraction. Now, when we get to talking a little bit more about remainders and so forth, be careful because a fraction does not mean a remainder. And in fact, remainders don't fully mean everything. Sometimes they meant that left to be. So fractions do help understand division some, and division helps understand fractions. We'll get to more of that when we get to fractions. All right, so let's go to what's called the division algorithm. Well, if there are 18 cookies and we want to package them in boxes that hold 6, well, we just simply start. We say, okay, what's 18 minus 6? It's 12. And what is, take one more box, 12 minus 6, it's 6. Take one more box, and I get another 6. So I've made 3 boxes, so 18 divided by 6 is 3. And that right there is the whole thing. Meaning, notice, in the beginning, I had 12. Well, that's bigger than 6. And then I had 6, which is equal to 6. We want to keep doing this subtraction process until this number here is somewhere between 0 and 5. It cannot be 6. It has to be some number between 0 and less than my number that I want, that I'm dividing by. So this repeated addition is a great way, and this gets what's called the division algorithm. And the remainder, obviously, is R. Hopefully, we like when R is 0. That's not always the case. And we'll talk about that in a minute. All right, so let's look at a different example. So consider for a second, we have 123, and we want to divide it by some number with a remainder of 13. Well, that algorithm simply says that means 123 is equal to some product, B times Q. I don't know what B and Q are, but B and Q plus 13. Well, B has to be bigger than 13. And because remember, the thing I'm dividing by has to be bigger than the remainder. So I can do this 123 minus 13 to get what my 2 numbers are left, which is 110. Now, again, we come here, and remember, one of my numbers has to be bigger than 13. Well, if we make a quick chart, we can actually see that the first 3 pairs on this chart, 1, 110, 2, 55, and 5, including and 22, all of them are bigger, have a number bigger than 13. So all of those are possible divisors, with 1, 2, and 5 being the quotients corresponding to them. All right, I know it's a lot. I'm just saying sometimes things are more open and with things like them are slightly different. Again, don't be fixated by just one strategy. Now I want to talk about one thing, and let's talk about dividing by 1 or dividing by 0. How do you divide by 0? Well, you can't, because that's saying I'm going to take some number and I'm going to break it up into 0 equal parts. Well, this doesn't make sense, because no matter what parts I break it up, it's more than 0. So we can't divide by 0. It is undefined. On the other hand, if I have 0 divided by a number, that is 0. So if I have $0 and I want to split it among 5 kids, well, each kid gets $0. That makes perfect sense. On the other hand, 0 divided by 0 is, well, not defined, because again, the first term we have up there has any number divided by 0 is undefined. So in reality, 0 divided by 0 is also undefined. There's a lot of issues that go on there. I won't get too technical on that one. Just when you're helping students, the big point is you cannot divide by 0. Please help them understand that. Now let's go back to the repeated subtraction method I kind of introduced. So in repeated subtraction, it's inverse operations. In other words, operations that undo each other. Multiplication and division kind of undo each other, and addition and subtraction undo each other. So when we do multiplication, which is repeated addition, division then becomes repeated subtraction. All right, let me demonstrate this for you by looking at this block right here. So let's do this. You can do this using the standard block. We could literally do this using repeated subtraction, but the problem is that would take an awful lot of subtraction, because 726, I'd have to take a lot of 6s out of it, but I could take these first 6. And then I could go 1, 2, 3, 4, 5, 6, take 6 blocks. 1, 2, 3, 4, 5, 6, 6 blocks, and keep doing. That's going to take a lot of circling of blocks to get myself out of here. But there's a different way in here, even beyond normal long division. So let's start with the hundreds blocks for a second. So let's take our big blocks. Well, if we just look at them, there is 6 already equal, which means I can give one of these big blocks to each of the 6 groups, which is good. So I get 100. Now let's take our tens. When we look at our tens places, that last hundredths block, we can break up into these 10 tens. Well, but notice now if I redistribute it, I now have 2 groups of 6 tens. So what's that mean? We have 100 each, and then 2 tens being also distributed each. Lastly, we can take our ones and break it up. So here's how repeated addition would look on this. So 700 minus 600, because we know that 600 is an easy subtraction. Gives me 126. Okay, I can't take any more 6s out of the first spot. But I can take 60. That gives me 66. Then I can take out 60 again. Gives me 66. I'm going to give me just 6. And then if I take out 6. Now notice the number of 6s I took out were 100, 10, 10, and 1. Add those together and you get 161. That is actually where this idea of the normal long division algorithm that many people learn comes from. Now, some people instead write it this way. Again, that looks, you probably learned it, I'm going to guess, more along this lines, but these ones are actually super useful from the standpoint of it keeps the place value. Here, sometimes students lose track of which place they're in, they're subtracting and so forth, and that causes a lot of problems. And so, again, what is traditional is not always the best. Please understand that. And just because you learned it that way, doesn't mean that was necessarily the best. It may have been the best your teachers knew, especially if they didn't know more. But now you know more, so you should try to help students try different ways and find the ones that help them the best, not the ones that parents are most keen. All right, one last comment about division, and that's order of operations. Sometimes we misunderstand order of operations. We'll come back to this, but everyone wants to use PEMDAS and all those. Please excuse my dear Aunt Sally. Those nice acronyms. Multiplication and division occur at the exact same time. So what we usually do is we perform them left to right. And if there's no parentheses, we do multiplication and division first, but multiplication does not occur before division. We do them in the exact order we have. So we go from left to right, doing whatever multiplication and division is first. And then we go back and we do all the addition and subtractions. So I hope that helps you understand division a little more. Good luck, and please let me know what questions you have.